Hey everyone, welcome back. Today we're going to talk about solving systems of linear equations by elimination. This process uses the addition property of equality. So if A equals B and C equals D, then if we add those two equations together, the result, A plus C, must also be equal to B plus D. The idea is to add two equations together to eliminate one of the variables. That's where the term elimination comes from. Let's look at the examples. Use the method of elimination to solve the system of equations. So example 1, notice that if we add these two equations together, that the negative 2x in the first equation and the positive 2x in the second equation would add together and cancel out or eliminate the x variable. So this system is set up perfect for elimination. We're just going to add, and we're going to add vertically. So negative 2x plus a positive 2x becomes 0. We eliminated the x variable. Then we have y plus a negative 4y. Well, that's a negative 3y equals negative 3 plus 0, negative 3. We simplify to negative 3y equals negative 3. We want to solve for y, so divide by negative 3. And we see that y equals 1. Now, remember that a solution gives us a point, an xy coordinate. So we found y, which is 1. Now that we know y, we can substitute that back in to either of our original equations and solve for our x. So let's substitute y equals 1 back into that second equation. So we have 2x minus 4y equals 0. And it doesn't matter which equation you pick, they'll both give you the same x value. So 2x minus 4 times our y, which is 1, equals 0. Or 2x minus 4 equals 0. Add that 4 to both sides. So we know that 2x equals 4. Now we need to divide by 2. Oops, I'm running out of room. And we know that x equals 2. So our coordinate is 2, 1. So remember, the answer of the point 2, 1 means that's where those two lines in our system intersect. Let's look at the next example. So notice here that if we add the first equation and the second equation, none of our variables will be eliminated. But if we could turn this x in the second equation into a negative x, when we add them, the x variable would disappear. So what we're going to do is we're going to keep our first equation, x plus 6y equals 2, and we're going to multiply our second equation by negative 1. And when we do that, the signs of all of our terms change. So we get negative x minus 3y equals 1. Now we can add these two equations together. And notice x plus a negative x, that eliminates the x variable, so we get 0. 6y plus a negative 3y, we get a positive 3y, equals 2 plus 1, or 3. So we have 3y equals 3. Divide by 3. And once again, y equals 1. So we'll put that up here, that 1 is the y value for our solution. And again, now that we know what y is, we can pick either of the original equations. Always use one of the originals, and we'll substitute that in and solve for x. So let's use that first equation this time. So we have x plus 6y equals 2. So x plus 6 times our y of 1 equals 2. Or x plus 6 equals 2. Subtract 6 from both sides, so we can isolate x and x becomes -4. So our answer then is the point -4, 1. Okay, let's look at a few more examples. So example 3, notice that when we add these two equations, none of the variables will be eliminated. So we need to alter one of the equations. I think it's going to be easiest to multiply the second equation by a -2. And notice if we do this, we'll get a -2y, which will cancel out with the positive 2y in the first equation. So our first equation remains the same, 3x plus 2y equals -16. We multiply the second equation by -2. So -4x minus 2y equals a positive 18. And then we can add those together. So 3x minus a 4x is a -1x. 2y minus 2y, the y's are eliminated, so that's 0. -16 plus a positive 18 is a positive 2. We simplify and we get -x equals 2. So divide by -1 to get a positive x equals -2. So here we solved the x coordinate is -2. So now we're going to substitute that x value in to one of the originals and find our y. So let's use the first one. 3x plus 2y equals -16. So 3 times -2 plus 2y equals -16. 3 times -2 is -6 plus 2y equals -16. So we add 6 to both sides because we need to isolate that y. And we're left with 2y equals -10. And then we can divide by 2. So y equals -5. So our solution here is -2, -5. Okay, example 4. Now, both of these equations have a lot of big coefficients. So here, it's probably easiest if we can shrink those down first. So notice that the first equation, we can divide the whole thing by 4 because 4 is a GCF here. So we pull out or factor out a 4 and we'd be left with x minus 2y equals 6. Now the second one, we could divide this one by 6. And that would simplify to x minus 2y equals 6. Now look at what we're left with. These two equations are identical, right? They're exactly the same. And remember what happens when we have identical equations. If we graph them, we end up with the exact same line. And when you have the exact same line for your system, it's infinite solutions. So here we get infinite solutions. Let's move on to page 2. Some application problems or word problems. So our first example is an airplane example. And an airplane is really just a boat in the sky. And what I mean by that is these airplane examples follow the exact same setup as the previous boat problems we saw. So we have two variables here. We're told that an airplane travels 3,000 miles with the wind in 5 hours and takes 6 hours for the return trip into the wind. Find the speed of the wind, that's our first variable, we'll call that W, and the speed of the airplane, We'll call this P for plane, and we're trying to find the speed of the plane without the wind. So just like the boat, we have the plane which is going in two different directions, right? First it's traveling with the wind, and then it's traveling into the wind. So if it's traveling with the wind, the plane and the wind are headed in the same direction. So that means the total speed would be the plane plus the wind, because the wind is helping to push the plane. And if it's traveling into the wind and the plane are going in opposite directions. So that means the speed of the plane is slowed down by the wind. Now, we also know that the distance is 3,000 miles, right? So let's put that over here. Distance is 3,000. And we know the time with the wind is 5 hours, and the time into the wind is 6 hours. So remember, when you have distance, rate, and time, you use the equation distance equals rate times time. Or, because we're trying to solve for the rate equals distance over time. So our first equation here with the wind, the plane plus the wind equals our rate, and that travels at a distance 3,000 miles per 5 hours. Or we can simplify, P plus W equals 600. And then when we're traveling into the wind, we're still traveling 3,000 miles for our distance, but our time is 6 hours. So then plane minus wind, that speed goes 500 miles per hour. And notice that these two equations are set up perfect for us to use elimination. Because when we add, the positive W and the negative W are going to cancel each other out. So let's add these two equations together. P plus P gives us 2P, and W plus a negative W, they cancel out. The W gets eliminated. And then 600 plus 500 is 1100. So we have 2P equals 1100. Or divide by 2, and we know that P equals 550. Or the plane speed is 550 miles per hour. Now, since we know that P is 550, we can substitute that back in to our equation. P plus W equals 600. So we have 550 plus W equals 600, which tells us that the wind speed is 50 miles per hour. Let's look at another type of example, another word problem. This is another word problem you'll see quite frequently. So a car radiator holds 2 gallons of fluid and initially is empty. If a mixture of water and antifreeze contains 70% antifreeze and another mixture contains 15% antifreeze, how much of each should be combined to fill the radiator with a 50% antifreeze mixture? This word problem has a lot going on. So start with the basics. We know that we have 2 containers that we're mixing together to equal a third container. So just draw a picture of it. So we have our first container, and we add that to our second container, and it gives us our third container. Now we can go back through and figure out what we know about each of these containers. So, a car radiator holds 2 gallons of fluid and initially is empty. And we're trying to fill this radiator, right? So, this would be our 2 gallons, the last bucket that we're trying to fill. Now, if a mixture of water and antifreeze contains 70% antifreeze and another mixture contains 15% antifreeze, how much of each should be combined? So those are the two that we need to combine, the 70% and the 15%. So we can just say that our first bucket has 70% and our second bucket has the 15%. So we're mixing those, and how much of each should be combined to fill the radiator, our 2-gallon radiator, with a 50% mixture. So we need our final mixture to be 50%. Now notice we're missing 2 variables. So we'll call those X and Y. And from this information, we get our 2 equations. So our first equation tells us that when we add X and Y, that's the quantity. So X equals the amount of 70% and Y equals the amount of 15%. So when we add X and Y, those two together have to total 2 gallons because we need a total mixture of 2 gallons. So our first equation is X plus Y equals 2. Now our second equation is based on the mixture. So we need 70% of X. And remember the word of means multiply. So we need 70X and we need 15% of Y. So 15Y. And that has to equal 50% of 2, or 50 times 2. So let's simplify this second equation. So 70x plus 15y equals 100. And we can bring our first equation over too, which is x plus y equals 2. Now we want to be able to easily add these equations together and have one of the variables eliminated. I like to pick the variable that has the smallest coefficient. So here that would be 15y. So we're going to multiply that first equation by negative 15. Because if I multiply by negative 15, my y term becomes negative 15y. And added with the positive 15y, they cancel out. So when I multiply, my first equation turns into negative 15x minus 15y equals negative 30. And my second equation stays the same. 70x plus 15y equals 100. So now let's add those two together. So negative 15x plus 70x becomes 55x. And negative 15y plus 15y, those cancel each other out. And it's equal to negative 30 plus 100, or 70. So 55x equals 70. So divide by 55, because we need to isolate the x, and we get x equals 70 over 55. And we can simplify that, right? 5 goes into each, so that's 14 over 11, or 1 3/11 gallon. So now that we know x, we can substitute our x back into one of our original equations and solve for y. Which equation is the easiest to substitute back into? That first equation. that x plus y equals 2. So x is 1 3/11 plus y equals 2. Subtract 1 3/11 from both sides, and you get that y equals 8/11 of a gallon. Okay, so what's our final solution then? Well, x, we need 1 3/11 gallon of 70% and 8/11 gallon of 15% to get 2 gallons of 50%. Remember, with these word problems, it's best to draw a picture. If you draw a picture, it gives you a better visual of what's going on, and you can start filling in the pieces of what you know and what you need to solve for. Have a question or a problem you want help with? Leave it in the comments and I'll include it in one of my videos. If this video was helpful, subscribe to my channel for more math tutorials. Thanks for watching. See you next time.